Hello everybody, this is our video solution to problem 3 from the Spring 2021 Math 302 final exam. This is a question about an ideal. So we have an ideal in the integers. It's generated by 10, 15, 20, and 25. And we want to show that this is actually a principal ideal, meaning it's generated by a single element. So the first observation, right, is that all of these numbers here, all these generators, are multiples of 5. And that's going to be relevant because, well, let's write down the definition of I. So, well, we could say, oh, it's the ideal generated by 10, 15, 20, and 25. But what does that mean? What this means, right, is the set of all expressions of the form 10 times an integer a plus 15 times some integer b plus 20 times some integer c, plus 25 times some integer d. Okay, so here a, b, c, and d are all integers. Okay, so that's actually what things look like. And you can see this expression here, I could factor a 5 out of it. So this is equal to 5 times 2a plus 3b plus 4c plus 5d. And so what that means is that every element of this ideal I is a multiple of 5 and hence is a subset of the ideal generated by 5. So this implies that I is contained in the ideal generated by 5. Right? Every element of I is a multiple of 5. All right. What I claim is that actually the reverse containment holds as well. Right? So claim is that the ideal generated by 5 is also a subset of I. Since we'll have reverse containments, we know that they'll be equal, and that is going to give us our conclusion. Okay, so how do we know that the ideal generated by 5 is an I? Well, first, 5 I claim is an element of I. And that we're going to know for sure by Bézout's lemma. We know we're going to be able to write 5 as a combination of, say, 10 and 15, because 5 is the greatest common divisor of 10 and 15. Of course, one doesn't really have to use the Bézout's lemma here. I mean, it's not that hard to get 5 in there. You say, well, we have 5 is equal to negative 1 times 10 plus 1 times 15. Right? And of course, I don't really need any of the other business, right? It was 0 times 20 plus 0 times 25. Okay, so just 15 minus 10. And this is an element of I, right? Because that's what elements of I look like. Multiples of 10 plus multiples of 15, etc. But once I know that 5 is an element of I, because I is an ideal, so as I is an ideal, it absorbs z multiplication. So I can multiply 5 by any integer and it'll still be an I. And hence, every multiple of 5, right? That is a multiple of z. Every multiple of 5, right? Every z multiple of 5 is an element of I. But that's precisely what the ideal generated by 5 is, right? The ideal generated by 5 is all z multiples of 5, right? So thus, the ideal generated by 5 is contained in I. So we conclude that the ideal generated by 5 is actually equal to I, and that was our goal, right? We wanted to show that I was a principal ideal generated by one element, and there it is.